The aim of this experiment is to compare the EMF of two given primary cells using a potentiometer. Apparatus: a potentiometer, a battery eliminator, galvanometer, resistance box of 0 to 10,000 ohms, jockey, one-way key, two-way key, Leclanche cell, Daniell cell, connecting wires, ammeter, voltmeter and rheostat. Daniell cell. Now, let us go through the brief description of Daniell cell. The EMF of the Daniell cell is 1.1 volts. A zinc rod is placed in a porous pot. This porous pot is filled with dilute sulfuric acid or acidulated zinc sulfate solution. The zinc rod acts as a negative terminal. The solution in the porous pot acts as an electrolyte. A copper vessel contains saturated copper sulfate solution. The copper vessel acts as a positive terminal. The copper sulfate acts as a depolarizer. Copper sulfate crystals are placed on the top of the vessel to maintain the concentration of the copper sulfate solution. Leclanche cell. Now, let us go through the brief description of the Leclanche cell. The EMF of the Leclanche cell is 1.5 volts. A zinc rod is placed in the ammonium chloride solution. The zinc rod acts as a negative terminal and the ammonium chloride solution acts as an electrolyte. A carbon rod is placed in the mixture of manganese dioxide and powdered carbon contained in a porous pot. The carbon rod acts as a positive terminal. The mixture of manganese dioxide and powdered carbon acts as a depolarizer. The internal resistance of the Leclanche cell varies from 0.5 ohms to 5 ohms. Now, let us see how a potentiometer compare the EMFs of two given primary cells. The positive terminals of the two cells of EMFs ES and E1 are connected together. A wire AB is included at their junction. The other end of the wire is connected to the negative terminal of the cell ES. The negative terminal of the cell E1 is connected to a galvanometer and a jockey which can slide over the wire. This wire acts as a voltage source for the lower loop of the cell E1. Now, at a point C on the wire AB, the jockey is pressed at different points on the wire. The galvanometer shows zero deflection. It can be understood that the potential at A is equal to potential at P. Potential at C is equal to potential at Q. Therefore, VPQ is equal to VAC. VPQ is equal to E1 minus IR. As the galvanometer is showing null deflection, it means that there is no current in the circuit. As a result, E1 is equal to VAC, as VAC is directly proportional to the length of the wire AC, L1. Therefore, E1 is directly proportional to the length of the wire AC, L1. Now, the cell E2 is also connected in the circuit with the help of a two-way key. Again, the jockey is pressed at different points on the wire until a zero deflection of the galvanometer is obtained. Let us say at point D on the wire AB, the balancing length is obtained. Then E2 is directly proportional to the length AD, L2. E1 is directly proportional to the length of the wire AC, L1. Thus, E1 divided by E2 is equal to length AC divided by length AD. Therefore, when two primary cells are given, the ratio of their EMFs is equal to ratio of their balancing lengths. E1 divided by E2 is equal to L1 divided by L2.
The 0 centimeter point of the potentiometer wire is made the high potential point by connecting it to the positive terminal of the power supply. The 400 centimeter point of the potentiometer wire is made the low potential point by connecting it to the negative terminal of the power supply through a plug key, an ammeter and a rheostat. The positive terminals of the Leclanche cell and the Daniell cell are connected to the high potential point of the potentiometer wire, which is the 0 centimeter point, to cancel their EMFs against the potential gradient of the potentiometer wire. The negative terminal of the Leclanche cell, which is the zinc rod, is connected to the end A of the two-way key. The negative terminal of the Daniell cell, which is again the zinc rod, is connected to the end B of the two-way key. The two-way key thus acts as a switch so that we can connect either the Leclanche cell or the Daniell cell to the circuit by inserting the plug in either the AC gap or the BC gap. The common terminal C of the two-way key is connected to the jockey through a galvanometer and a resistance box.
least count of voltmeter is equal to 0.05 volts. Range of voltmeter is equal to 0 to 3 volts. Least count of ammeter is equal to 0 to 3 amperes. Range of ammeter is equal to 0.05 amperes. Number of wires on the potentiometer board are 4. Drop of potential across the battery eliminator E used in this experiment is 4 volts. Drop of potential across the Leclanche cell E1 is equal to 1.5 volts. Drop of the potential across the Daniell cell E2 is equal to 1.1 volts. Therefore, E is greater than E1 plus E2. Ammeter reading A is equal to 0.20 amperes. Balance point when E1 Leclanche cell is connected in the circuit L1 centimeters. In trial 1, it was 222 centimeters. In trial 2, it was 220 centimeters. Mean L1 is 221 centimeters. Balance point when E2 Daniell cell is connected in the circuit L2 centimeters. In trial 1, the balancing point was observed at 154 centimeters. In trial 2, it was 157 centimeters. Therefore, mean L2 is 155.5 centimeters. Therefore, E1 by E2 is equal to L1 by L2. That is 221 by 155.5. That is 1.42. Similarly, balance points for cells E1, E2, L1, L2 centimeters respectively are obtained for different values of current in the circuit by adjusting the rheostat. The values obtained are as follows. Mean value of emfs is equal to 1.42 plus 1.39, 1.41 plus 1.41 divided by 4, that is 1.40. The connections should be neat, clean and tight. The key should be closed only when we are taking the readings. The jockey should not be pressed over the potentiometer wire. The ammeter reading should remain constant for a particular set of observations. If necessary, by adjusting the rheostat, make sure that the ammeter reading remains constant. The EMF of the battery should be greater than the sum of the EMFs of the two cells. Some high resistance should be introduced in the circuit before moving the jockey along the potentiometer wires. All the positive terminals of the battery eliminator, Daniell cell and the Leclanche cell should be connected at one point.